Okay, example 1 on 5-1 day 1. I'm going to start with the what's called the unit circle. Okay, this will become your best friend in trigonometry, the unit circle. Imagine a circle centered at 0, 0 with a radius of 1. All right. So if I go out here, it's 1. Up here, it's 1. Over there, it's 1. Down there, it's 1. The coordinates at this point are 1, 0. The coordinates at that point are 0, 1. And we're going to actually work with the coordinates down the road. But again, imagine a unit circle always centered at the origin when you're dealing with trigonometry, which again we're going to get into pretty hardcore this chapter, all the sine, cosine stuff, and then we're going to apply stuff in 6 and 7, chapter 6 and 7. But if we're dealing with the unit circle, we're going to start at 0 degrees or 0 radians. Take your pick of what unit you want to work with, degrees or radians. And we always go in a counterclockwise positive direction and a clockwise negative direction. Right? So if you see a positive angle, you're going counterclockwise, negative angle clockwise, because that's what the guys who invented trigonometry decided. Some people think that's backwards, but that's the correct one. All right. Thinking of quadrants also, because we do a lot of quadrant stuff in this. The first quadrant is the top right-hand quadrant, then you go in a counterclockwise fashion to get the rest of them. Second quadrant over here, third quadrant over here, fourth quadrant over here. Every next spot is 90 degrees more. So if I go up to here, I'm up to 90 degrees. If I go over to here, I'm at 180 degrees. If I go down here, I'm at 270 degrees. And if I go up here, I'm at 360 degrees. Okay. If I go up to there, then I'm at 450, right? And then 540, and then 630, and then 720, and so on. So you can keep on going. If you keep going around the circle again and again and again, you keep getting bigger and bigger angles, okay? Suppose you're at some angle measure, I don't know, let's just say 30 degrees. That's about here. So that's a 30-degree angle. We'll pretend. All right. If I go all the way around the circle one more time and end up there where I'm at then, 390, very good. All right, so let's look at the 390-degree angle and compare, okay? Looking at the blue and the red, do they look about the same?
About.
The only slight difference is I slid this down just a little bit so we could actually see the blue, but that's right where it's at, right? You can still kind of see the blue halo around the red thing, right? They're exactly the same thing, right? Those are called coterminal angles. Where the angle ends up is the terminal side of the angle. So if they end up at the same spot, they're coterminal. They've got the same terminal side. All right. So 390 and 30 are just as good as each other. They're perfectly the same. All right. Getting back to the idea of radians, 0 radians, we got up here pi over 2 radians. Over here we got pi radians. Down here we got 3 pi over 2 radians. And over here we've got 2 pi radians. All right. 2 different ways to measure angles. That's all those are. All right. Getting to the radian idea, if this is a radius of 1, what's the circumference of the circle? Circumference formula being 2 pi r.
So it would be 2 pi.
2 pi, right? So you see 2 pi radians, the circumference. That's all radian is. It's if you had a circle of radius 1, it's how far around the circle you've gone. That's the circumference. So from here to here, pi over 2 radians is the circumference. So that's all that is. All right. So, and that's how radians were invented. Okay, they're an actual measurement. They're an actual length. So that's why not getting into great detail, but in calculus we use radians instead of degrees because it's an actual real thing where degrees were invented. Degrees are an invented thing where radians are actually what they are. So anyway. So the main idea for examples 1 and 2 though is coterminal angles. In order to get a coterminal measure, all you have to do is either add or subtract 360. If I add 360 to 30, I get 390. If I subtract 360 from 390, I get 30. The magical numbers we want are between 0 and 360 though. That's where we want to be always. Always between 0 and 360. So if I'm less than 0, that says than. Less than 0, I'm going to add 360 again and again and again, or 2 pi again and again and again, to get to an angle measure inside 0 and 360, or 0 and 2 pi. If it's larger, or let's go greater than 360, I'm going to subtract 360 or 2 pi again and again and again until I get what I'm looking for. All right. Now, subtracting and adding 360, easy. Adding and subtracting 2 pi also easy, but a lot of times pi's numbers are in fractional form. So considering pi in fractional form, 2 pi is the same as 4 pi over 2. It's the same as 6 pi over 3. It's the same as 8 pi over 4. That looks like a not equal to now. It's the same as 12 pi over 6. Okay. If you got it in fraction form, just get a common denominator. But all those are 2 pi. So adding 2 pi, subtracting 2 pi is adding and subtracting those numbers. All right. So if you look at example 1, given theta is equal to 40 degrees, find the measure, if possible, of its complement and supplement. So that's not talking about coterminal, right? That's just asking about complement and supplement. We did that back in Algebra 1. Complementary angles add up to? And supplementary add up to? 180. All right, so, and it says, if possible, meaning that if it doesn't have a complement, skip it. It wouldn't have a complement if it's bigger than 90, right? So it's got to add up to 90. We'd have to get a negative angle. We're not going to do that. So, complement plus the angle measure is equal to 90. Supplement plus the angle measure is equal to 180. That's all you have to do a complement and supplement problem. If that were in radians, complement plus angle measure equals pi over 2. Supplement plus angle measure equals pi. All right, so again, using the radian measures instead of degree measures if you're in radians. And again, if it doesn't have this degree symbol, you're in radians. If it says theta equals 1, that's 1 radian, all right, not 1 degree. All right, so don't assume degrees, only degrees if it's got the symbol. So the complement of this angle is going to be 50 degrees. The supplement of this angle is going to be 180